Alright, so today we're going to talk about compound inequalities. So we just said that compound means two, or combining. So how many inequalities do you think we would have? We would have two inequalities. Does everybody attach this to their notebook before we go any further? So, I don't want you to write this down, but I want us to think about something. This is what a compound inequality looks like. So before you yell anything out, I want you to think for like 10 seconds and think about how we could solve this.
I got it.
Nope, we're not talking yet. Just wait, think. All right, Manny, how do you think we could solve it?
By adding 3 on the opposite side, like the 10, and then on the opposite side of the symbols.
Okay, does anybody think of a different way than what he said? He said add 3 across. Subtract 5. Where would you subtract 5?
Both sides.
The 10 and the 5, but where else? So if we just had this right here, what would we do? We'd subtract 5 here, and we'd subtract 5 here, correct? So if I just had this, what would I do? You'd subtract 5 here and here, correct? Is everybody with me? Are you looking at the board and focusing?
Yes.
So what do you think we would do now? From all the sides. So you would subtract 5 here, here, and here. Everywhere. So what we're going to do today, this is called an AND compound. We're going to talk about what it looks like to graph AND compounds. Are you ready? All right, open this. So a graph means that it would be, AND means that it would be x is greater than or equal to 2 and x is less than or equal to 6. So we have 2 different kinds of answers this time. And the graph of it and statements will always overlap. So that means that the answers will overlap, the numbers will overlap, and when we graph it, that will also overlap. If it does not overlap, it has no solution. And then it says both inequalities have to be true for the compound to be true. So what that means when it's overlapping, our example here, and don't write this, I just want to show you. What numbers are greater than or equal to 2? And? Okay. But then it says, and x is less than or equal to 6. So what numbers are less than or equal to 6? Y'all know that other people besides Manny can answer, right? All right. So we have 2 answers right here, correct? How many dots do you think we're going to have on our graph?
3.
We're going to have 2 dots. Where would we put a dot at? Would we put an open or closed circle? Closed. Where else would we put a dot? Now, it says that x is greater than or equal to 2. What numbers are greater than or equal to 2? This one? And what numbers are less than or equal to 6? That's all you do. So do you see how the graphs overlap? We connect them. So when it's an and situation, you connect your dots. You make them connect in the middle. So if you have one that's greater than and one that's less than, the solution graph is going to look like this. So this says greater than and less than. Our graph connects. Damien, we're writing. It is. So the reason it connected is because it says that it's greater than 2 and it's less than 6, so we connected them. So if I said that it's greater than 2 and it's greater than 6, what would it look like? If this said x was greater than or equal to 6, what would also happen here? So which way would they go? They would both be going to the right, so it would look like this. So this solution looks like this. So case 1 is if you have a greater than and a less than. Case 2 is if they're both greater than, or they could both be less than, right? If they both said less than, which way would it go?
Yeah.
Fantastic. Now, these two are going in opposite directions, and do they overlap at all?
No.
So what happens if they don't overlap? What does it say if it does not overlap in our directions? No solution. You would just write no solution. Don't put a 0 through a line through it because that means 0. Just write no solution. Yeah. Don't do that. It does. It evolves.
Just from one thing to another.
Yeah. So, if they overlap like this, they connect. If they're going the same way, it looks like this. And if they don't overlap at all, what's our answer?
No solution.
No solution. Do you think you're ready to work out a problem?
Yeah. No. I don't know.
Maybe you should pay attention, then you might be ready. You had a moment? A moment of lapsing in what was happening? Alright, so I'm going to turn my paper over. And my and problems are going to be in blue on the back. Again, you live in Alabaster. Dang. I don't know nothing. I'm going to stop. Alright, 23B. Example 1, solve and graph. Yeah. You're welcome. Thank you. So your backpack's gonna kill me.
Well, sorry. Christian's background is
Okay, so how do you guys think we would first solve this?
Subtract 4.
Subtract 4 where?
Everywhere.
Would we subtract 4 from the 2x? Why?
Because it's variable.
Yep, the 4, 12, and negative 8. So we subtract 4 here, here, and here. So everywhere except the 2x. Because remember, it's 2 inequalities. 2 problems. Kill that one. I mean, mark that one. Cancel it out. All right, so bring down your 2x. And then you're going to keep your signs each time. Keep your signs. Don't change those. All right, what is 12 minus 4?
2. I just guessed. I guessed.
7.
We shouldn't guess at that. No.
8.
8. What is happening?
I don't get 8.
All right, what's negative 8 minus 4? Negative 12. Sweet potatoes. Sweet potatoes.
That's what I thought the first one that you said, I thought you were saying negative 8 minus 4. That's what I said 2.
That's still not 2. Okay.
Can I start marrying an episode?
No, don't do it. All right, are we done?
Yo.
You did it.
We're not done. What else do we have to do?
About like 2.
We got to get rid of that 2. We have to divide. So where are we going to divide?
Everywhere.
Everywhere. Everywhere. Are we keeping our signs?
Yes.
Okay, why would we divide that 2? Why would we divide the 2? Why did we divide this?
Because you need to keep the variable by itself. Or get the variable by itself.
All right, what's 8 divided by 2?
4.
What's negative 12 divided by 2?
6.
Negative 6. Now we get to graph it. Get excited.
Oh my god.
It's so easy. It's so easy. I promise.
Don't you guys divide?
Graphing makes me mad. I don't know. It just gets me more, too much work, more work.
It's not. Don't be lazy.
I know it's like, what's the point in having all these?
All right, put 0 in the middle. All right, how many dots are we going to have?
12.
Or circles?
2. You said dots at first.
I'm sorry, circles. 2, because we have how many answers? We have 2 answers. So where are we going to put our circles? Negative 6 and 4. What kind of circle are we going to put on 4?
Open.
An open circle. Awesome. What kind of circle are we going to put on negative 6?
Close.
Look at Manny go. He may not do his homework, but he can answer in class.
Yo.
All right, now we have to shade. We have to connect our dots. Now, it's an and situation. Now, this says x is less than 4, correct? And this says x is what?
Equal to.
Greater than, because it's eating the x, so that would be greater than or equal to negative 6. So remember, right here, we said if it was a greater than and a less than, we would connect. Do we have a greater than and a less than?
Yes.
Connect.
Question.
Yes.
Did you have to flip any signs?
Not that time. Why did we not flip that time? We didn't multiply or divide by a negative. So we divided by a positive 2, so we didn't flip anything. Yes, Mackenzie? Oh, okay. So if this was a negative 2, we would flip. Are we finished?
Yeah, I'm just kidding.
Yes, if this 2 in the middle was negative, then we would flip. All right. Uno más.
Oh, my pinky toe.
You have another one for homework. All right, so this one's right now, and then we're going to have one for homework. So solve and graph this one right now. And remember, you have the steps in front of you. Your face cracks me up.
Why?
That's not what I meant.